Episode 3 is all about writing molecular formulas given the chemical names. The first one is dioxygen difluoride. So here we have these are the prefixes, and these are covalent compounds because the prefixes are only used in naming covalent compounds. Now here we have dioxygen, it means we have two atoms of oxygen. Then we have difluoride, it means two atoms of fluorine. That's the chemical formula or the molecular formula for the first compound. Next one, we have potassium sulfate. So this one is an ionic compound because here potassium is a metal. So pag merong metal, that one might be an ionic compound. So here we have potassium, then we have the sulfate, SO4. Again, for the ionic compounds, we don't use the prefixes. So this name doesn't tell us how much of potassium is here or how much sulfate is in the compound. So we need to check the overall charge, and then we need to make sure that the overall charge of the compound must be neutral or zero. So here the charge of potassium ion is positive 1, that is positive 1. Then for the sulfate, the charge is negative 2. So obviously this one is not neutral because we have negative 2 from the SO4, then positive 1 from the potassium. So how do we get an overall charge of 0 from this one? So here we have 2 and 1. So the LCD between the two is 2. So I must get negative 2 from this one, and I must get positive 2 from the potassium. So it's already here. I already have negative 2 from the sulfate, but I still have positive 1 from the potassium. So how can I get positive 2 from the potassium? So here each of the potassium ion has a charge of positive 1. I can get a positive 2 by having dalawa. So I need dalawang potassium ion. So if I have dalawang potassium ion, each of them has a charge of positive 1. Overall, I'll have a charge of positive 2. So this is the chemical formula for potassium sulfate. Again, we have K2, then we have SO4. Again, this number is not visible, or it's not obvious from the chemical name because again we don't use the prefixes for naming ionic compounds. Next we have dinitrogen pentoxide. So here we have the prefixes. So this one is a covalent compound, and here just follow the prefixes, then the name of the elements in the compound. We have dinitrogen, then we have pentoxide, oxide oxygen, then penta 5. Next we have bromine monofluoride. So here we have the prefix mono. So mono, so this one is a covalent compound. So here we have bromine, then we have monofluoride, we have one fluorine atom. Next we have cobalt 2 phosphate. Here we have this 2 inside the parenthesis. This one tells the charge of the ion. So this one is an ionic compound. So for cobalt, that is CO. Then for the phosphate, we could look it here. We have PO4. Next, we need to check the overall charge of the compound. So for cobalt, again, it can be positive 2 or positive 3, but it's already given here that the charge of the cobalt in this compound is positive 2. So we have positive 2 sa cobalt. Then for the PO4, the charge of a phosphate is negative 3. So overall, it's still not neutral because 2 and then 3. So what's the LCD of 2 and 3? That is 6, right? So I must get negative 6 from the PO4, then I must get positive 6 from the cobalt. Now how can I get this? So again, each of the cobalt has a charge of positive 2. How can I make this positive 6? I can do that by having tatlo. So tatlong cobalt na ion, because that is 3 times positive 2, we have positive 6. And how about for the phosphate? So I have negative 3 for 1. I can get negative 6 by multiplying or having a double amount of PO4 because negative 3 times 2 is negative 6. So again, the chemical formula for cobalt 2 phosphate is this one. We have cobalt tatlo, then we have PO4 na dalawa. Again, we don't include the charges on the final chemical formula. Next, we have cadmium oxide. So here we have cadmium. So this one is over here. So this one is a metal. Again, this ladder, this separates the metals from the non-metals. We have cadmium, then we have oxide. This is oxygen. Let's check the overall charge of the compound. For cadmium, the charge is positive 2. Then for the oxygen, the charge is negative 2. So this one is already neutral, so I don't need to add any subscript here. So again, the final chemical formula for this is cadmium oxide. So one cadmium, then one oxygen atom or one oxygen ion. Next, we have ammonium sulfide. Ammonium, so this one is a polyatomic ion. Ammonium is NH4, NH4. Then for sulfide, it's not actually here, but it's on the book. You can open your book on the last pages. There we have the more complete or more list of negative common ions. Over there on page 241, we have sulfide, that is S. And then next, again, we need to check on the charge of the ions here. So for sulfide, the charge for sulfide is negative 2. So again, this one is negative 2. How about for the ammonium? For the ammonium, that is positive 1. Again, pag kawalang number, it means positive 1. So here it's not neutral, obviously. So how can we make this neutral? We have 1 and 2. The LCD is 2, right? So I need negative 2 from the sulfide. Then I need positive 2 from the NH4. I only have positive 1 for each of the NH4. I can get positive 2. I can get positive 2 by having dalawang ammonium. So again, I need to put this one on a parenthesis, and then we put the subscript after the parenthesis. So again, for this one, we have this one, NH4. Then again, we have dalawa. Then isang sulfide. Okay, so this is the chemical formula for this compound. Next, we have boron trihydride. So this one we have the prefix tri. So this one is boron. Then we have hydrogen. We have tatlo. This is the chemical formula for this one. Next, we have lithium dichromate. Now be careful about this one because this one is not a covalent compound because this one refers to this ion. And also if you look here, lithium is a metal. And again, pag metal, the compound is an ionic compound. So here we have lithium. Then for the dichromate is over here. We have Cr2O7. Next, I need to check the overall charge of the compound. The charge of lithium is positive 1. And then the charge of dichromate is negative 2. So again, it's still not neutral. So the LCD is 2, right? So I must get negative 2 from this, then positive 2 from the lithium. So how can I get positive 2 from lithium? I need to double the amount of lithium. Then again, I already have negative 2 from the dichromate. So this is the final chemical formula for lithium dichromate.